Can you all hear me now? Sorry, I just did a whole intro with no sound. So, as I was saying, I hope everyone's having a good Wednesday. Welcome to Arrays with Aki. And today we're actually going to be making another game. And this time it's a little bit more of a game. We're making Tic-Tac-Toe. So if you go down into the link in the description below, you'll be able to find the GitHub link. If you know how to use GitHub, feel free to clone this like you normally would. If not, just go download this. It's called Tic-Tac-Toe. Oh, I didn't realize my sound was gone. My mic just cut out for some reason. My audio unit, as they say. So if you open it up, you'll see something like this. I'm sure by now you already have your preferred code editor, or if you downloaded Sublime from the last time that we made a game, you can use that. So you can use anything you like. We're sort of doing JavaScript again here for today. And so if you remember how to open it, it's just you open up the HTML file inside of any browser of your choice, and then you're gonna wanna fill in all the code here today with us in tictactoe.js. So that's gonna be where all of our work is. Okay, perfect. So this is like a little template that I made for everyone. You can see like there's some buttons that you can click. This is mostly just a tic-tac-toe board, and there's like a little message down here. You can click these to put either X's or O's into the board. Right now there are no win conditions because that's what we're going to be filling in. So you can't actually win this game yet. You can tie it, but that's about it. And you can also reset it, which is kind of neat in case you don't want to be stuck playing on one single tic-tac-toe match the entire time. Okay, perfect. So before we do that, can you tell me like how we can represent each of these squares to a computer? So this is going to be something a little bit new. We know how to do variables now, and we know that, like, for example, we can give the computer a variable and put like some data in it, right? So feasibly you could put like an X in one of these, or an O in one of these, or just nothing to represent nothing in the square. You could also represent it with numbers, yeah, for sure. Like you could put maybe 0 for O's and then 1s for X's, or I guess 0 for nothing makes more sense. Or you could put like a -1 for nothing. So it could really be any representation you like, as long as you sort of have that mapping in your own head, so that you can feed the computer the instructions of how to work with it. And so if we think about it that way, though, we have how many? 9 squares here for the board. It's going to be a little bit tedious to go like var first equals like nothing, and then we've got to do like second, right, and then third, right, and etc. So we don't want to do this 9 times, right? That's going to be a really big hassle. And so something that we can actually use is called an array. And an array is kind of like, we represent it by the square. It's like a list of variables that the computer can store in its head. So it knows that when you say whatever you call this variable, board, like you mean everything in this board, not just like one single point of information, if that makes sense. Yeah, arrays are kind of hype. So it could be anything you want. Like inside here, you can have numbers, like you said. You can have, so this is kind of generally how arrays are written out. It's like the same as any other variable, but you have square brackets outside of the actual data that you're putting in it, and then commas between each of the little data things that you give the computer there. And so like feasibly we could represent this board. We can use like, what is it? We can use like spaces for nothing. And then if a player puts something, we can put an X, right? Or an O if it's O's turn, right? Yes, be careful doing arrays in JavaScript. It is a scripting language, but you won't really hit that with this game, hopefully, unless you do something really weird. technically everything in JavaScript is created as an object, and that's why like data types don't quite act exactly how you expect them sometimes. But I think as long as we're sort of in this space, like we're not really going to be doing anything that will hit problems. So that's why I swapped this all over to C++ for the last lesson on data types. If you missed that, feel free to go ahead and look at it. Data types are very important for modern programming most of the time. And they're just a good concept to know in general. Should send this to Yandev. Yes, exactly. We're going to have a lot of if statements today. We actually get to put sort of everything that we had into use today. So we get to use all our if conditions, we get to use our variables. We could even use our loops if we really wanted to. So there's a section here that asks you to either do it in sort of loops or in with conditions only. So you can do it either of the ways. The conditions one is a little bit easier, but if you want to practice the for loops, go for it, because that's going to be really helpful for you later on. But before we do that, let's take a look at all of the variables that we have available to us right now. So you can see that we have a board and a 2D board. So I'm actually going to introduce the 2D board a little bit later. We're going to do this two ways. And the first one that you need to worry about is just board. And so you can see like there are 9 slots in this board. You can count it, but you can also just take my word for it. So I wouldn't lie to you about that, surely. But you can see like each of these, I put dashes instead of spaces just so it's easier to see when we print them out. But you can see like each space right now is empty, so we have it represented as a dash, right? And so what we can do with this, here actually we also have a winner variable, and so that's space for the winner of the game, so either player X or player O, or it's just nothing for there's no winner yet. So that's all the information that we have right now. Can I make the text bigger? Yes, I sure can. There you go. I forget sometimes that it's a lot smaller on my screen. So hopefully this is a good size. This is it looks huge on my screen, but I know that it doesn't look huge on your screen. But perfect. So these two are the ones we'll be using right now. And there are also 2 here. I know we haven't learned functions yet, but just know that there's a variable somewhere else in the code called player, and that'll tell you which letter the next one being placed is, and I, which is the index of the array, like the position within here where the player has just placed their letter. And so if we look at arrays, how are they indexed? Well, like how would we access like this space, for example? So this would be 1, 2, 3, 4, 5, which would be this middle space, right? And I think if you caught some of my earlier lessons, you'll remember that programmers and computers count starting from 0. And so each of these are actually just numbered. So this one is 0, this is index 1, this space is index 2, 3, and etc., right? So it's kind of pretty simple. You can just look at which one it is. And so going down from here, it would actually be 0, 1, 2, 3, 4, 5, 6, 7, 8. Kind of like that, right? All right, so knowing that here, we can actually leave this here as a comment so we can reference it later on, but it's also down here in case we want to see it as a grid format. So the first thing that we have to consider is the different ways that we can win within a game of tic-tac-toe, right? So hopefully everyone here is familiar with tic-tac-toe, actually. I kind of made an assumption there, but I think it's a pretty safe assumption to make. Basically, each player takes turns putting their letter, so it'll either be an X or O, and then once they have 3 in a row, then they win, right? But let's think of the ways that we can have something in 3 in a row, right? So what positions can it be? It can be vertically, right? And normally, I guess this would be all X's. It can be vertically. It can also be horizontally, right? You can win this way. And then a different one is you can also have it diagonally, right? And diagonal both ways. So you can also have it this way. Oh, that's the wrong one. So these are sort of all the win conditions. And if you think about it, like all the verticals and horizontals, like it can be the first row, right? It can be the second row, it can be the third row, it can be the first column, the second column, the third column, sort of all of those, right? Yeah, even if you're not familiar with it, hopefully that sort of explained it to you. It's a little bonus lesson for you. Yeah, and you now know how to play tic-tac-toe, so you're welcome. But let's sort of break that down for ourselves, right? So we're going to be writing a lot of if conditions, and we can sort of start with maybe winning within a row, and then we can break it down into like, well, let's do the conditions with the columns, and then let's do the diagonal ones. But before all of that, it might be a really helpful thing for us to print out what our array actually is, right? Your game always ends in draws, yes. If you've downloaded the code, this is actually like exactly what I have here. It's a template code for you, so we're gonna fill it out today. So it's not the full game. If you actually go into a branch, so the branch is just called for. Here, I can show it. So if you go into the pull request, actually you can see it. There are the solutions here that I've written out for you already. But the one that you have right now is sort of all the bare bones of it. So if you go in here, you can take a look at, I've put like 2 different solutions here, one with for loops and one with the regular conditions, and also the 2D version of that. So if you get stuck, take a look at that, but I would suggest like trying to do this yourself, right? Yes, exactly. Now you know how to win every tic-tac-toe game. That's what this is all about. It's tic-tac-toe strategy. But let's try to print out this board, right? And so that way, like as we're coding everything, like we'll know how to sort of do things. And so for JavaScript, an easy cheat that you can do is you can just print out the entire variable regardless of what it is, right? And you'll remember, like if you do Control-Shift-I or Control-Shift-J within your browser, you can open up the console. And so if I do that, what's it gonna print out once I click on something? So it's actually gonna show the board, right? But this isn't the way that you would normally print out arrays in other languages. This is kind of a special thing that JavaScript does because of the fact that everything is an object. And so I'm actually going to teach you how you would normally print it out if you didn't have this, right? And you can see like position 4 already has the X, or this is position 5 technically because it starts from 0. So 0, 1, 2, 3, 4, right? So that's where we've placed the X so far. And this is a useful way for you to sort of see if your code is working or not, and just see like the state of what the computer knows about the board at the time. And so we're gonna do this the proper way, but that's an easy way to do in case you really get stuck and you couldn't be bothered to do anything. But let's make a for loop, right? Because here's how you actually, here, let me show you this first. Here's how you actually access each index of the array specifically. And so you can do something like board at 0, right? So you kind of use the same square brackets to address whichever space that you want to be able to print out. So if you do board at 0, the computer will look and say, oh, board is an array, and then it'll look at the 0th space, right? So board at 0, it knows is going to be this space. And an easy way to see that right now, I think, is we're gonna temporarily like get rid of this, and then we're gonna put like 0, and then a 1, and then a 2. This is just so you can sort of learn what addressing arrays looks like and how you can sort of use them, right? And so if we do that board at 0, what will it print out for us? Oh, it prints out X, sorry, because it actually updates it in my other script. Hang on. Let me just take all of this out right now. Right. Except this. So we need that. And so if we update it now, you'll actually see, if I don't reset the board, that it's printing out 0, right? Which is what we've made the board have at the index 0. And so we can keep doing that, right? Like we can do like 0 and then print out 1, right? So it prints out both of these. And then we can do 3, 4, 5, 6, 7, 8, 9, right? 2, 3, 4, 5, 6, 7, 8. So that's all 9 of the squares within the array, because we have 9 numbers in here starting from 0. And so yeah, that's all well and good. It prints out all of them, right? But we don't want to have to copy and paste everything, right? 9 is already a lot, but imagine you have a grid within like a really big game. Say you're playing like an RPG or something with a bunch of different tiles. Now, obviously, you don't want to copy like hundreds or thousands of lines just to print out like what's within each tile, right? And so what we can actually do for this, like if you remember, loops are really good for doing things over and over, right? It's kind of like factoring out in math, but for computers. So the computer knows to do like a certain action, and each time it does the action, we can make it adjust a little bit so that it's actually doing what we want. So like, for example, if we print it out, let's do variable I equals 0, I is less than 9, right? And then plus plus I. So this is the condition, or this is what a for loop looks like, right? So that's the general syntax for it. And essentially what we can do is take one of these commands and do it over and over again, right? So we can take that. What will this print out, first of all? What will this print out? We can try it out. If you don't know the answer to something, you can just take a look at what the computer does. So you don't actually have to guess, you can just have the computer do it for you. And so this actually prints out 0 9 times. And you'll remember that 0 is what we put into the 0th index. Maybe we can put them as letters so it's a little bit easier to see, so you don't get confused between like the index number and the actual contents of the array, right? And so if I do that, it's going to print out A 9 times. Now what do I do if I wanted to do what we did before, where we have every single one of the spaces in the array printing out? Well, notice how we say we want the 0th index every time, but we don't want the 0th index every time, right? We want the 0th and then the 1st and then the 2nd and then the 3rd, right? And then all the way until 8. And so we already have a variable here that sort of updates that number each iteration of the loop, right? So each time the computer does this once, and then the next time this is going to be incremented 1. So I is going to be 0, and then I is going to be 1, and then I is going to be 2. And so we can actually reuse that variable, right? So instead of 0, we don't want it to print out the 0th thing 9 times. We actually want it to print out each space of the array 1 time, right? But we're going to have 9 in total. And so if we refresh this now, and then we try it, right, see, now it prints out all of them, which is exactly what we want, right? And so we can take this out now and then use it to print out our actual array, right? And then I'm gonna put all these back so that it's actually related to our tic-tac-toe game. But you don't need to worry about any of the other tab. Just worry about everything in this file right now. And so if we refresh that now, every time we click something, you'll see, oh, there are 4 dashes and then the X that we have and then 4 more dashes, right? But obviously, like, this isn't an easy way to see it in JavaScript. And so we're gonna need to do a little bit of formatting in order for this to actually look like a board that we can feasibly read, right? And so instead of doing console.log each time, we can actually store this in another variable first before we're ready to print it. because each time we do console.log, it actually does it on a separate line. And then if you're printing out the same thing, then what your browser does is it'll compress everything into one line, right? And this is a little bit specific to JavaScript and web dev in general, but this is still like pretty good practice for you to be able to work with loops like this in order to print out something in a format that you want, right? And so before moving on to the actual game, what we can do is, for example, we can have a variable called, maybe we'll call it print or something. You can name it anything you want, and then we'll just make it an empty string, right? And if you remember, like a string can be like any words or any characters that you want. It can really be anything as long as it's within two single brackets, or not single brackets, single quotations or double quotations, as long as you're consistent about which one you use, right? So, like for example, if we print out print, right? Let's get rid of everything in the loop right now. So this will print out everything in here. So that was just a quick refresher of what strings looks like within a variable. And so we're going to start with an empty string because we don't want to put anything in it yet. We want to fill it out with the loop that we're making, right? And then we can actually move the printing of this print. Maybe we can call it something else. Print might be a little bit confusing, but we can move the printing of the output at the end of whatever we do to it, right? What happens if you vary between single quote and double quote? Well, it depends on what you're doing. So if you're using two single quotes as the actual indication that here is the string that you want to use, then you can actually put double quotes inside and it'll just sort of count that as another character. So this will actually print this out with the quotation marks, right? So if I do this, you'll actually see double quotation marks, which is nice because the computer's only reading the outer single quotes as the sort of, it's like the key to when it starts and stops this variable, right? So it's interpreting this as everything in between the single quotes you can print out as just letters, right? And that's why if you put another single quote in here, it'll get really confused. Like you can already see like it's kind of yelling at me right now about having 3 single quotation marks because it thinks like this is the string, right? Like this double quote all the way to F, but then the rest of this is sort of invalid syntax because now you have an uneven number of single quotations. And the way that we fix that is you can escape the single quotation inside. And what this backslash does is it tells the computer, oh, treat this as a character, not as part of the code. So if we print that out, then it'll actually just show this. It should actually show the single quote, but maybe JavaScript does something weird with it because sometimes that's just a thing, you know? Oh, no, it doesn't. I just hadn't refreshed it properly. I hadn't saved it properly. So does JS support string? I can't actually see what characters you put. Hang on, let me copy and paste them. Is this three double quotes? Or are you asking if it supports string? It technically does support string, but there are like supersets of JavaScript that you can use to actually support it. Otherwise, it's mostly counted as a variable. So with the sort of functions that you can use on strings. Oh, with 3 quotes for a string. I don't think it does. I don't think it does at its base. Let's try it actually. Yes, it does not. It does not like that. Some languages do, but not JavaScript. So, but you can switch up single quote and double quote throughout the code, just not the same string. Yeah, exactly. So if I do like word 1, right? And then I made another variable here. Let's call it out2. It's not the best naming convention, but we can say word 2, but use double quotes, right? So you can do that. You can print out and out2, And then that'll actually print out both of them and it's fine, right? Yep, you could totally do that. Generally, you want to keep it consistent because it helps you remember what you used, and therefore you're not like confusing yourself in the middle and like accidentally switching one. Because if you switch like a single quote with a double quote and then you have like a million lines of code, it's going to be really hard to pinpoint like where exactly you went wrong, right? So you're going to kick yourself if like you accidentally use a single quote instead of a double quote somewhere, and then your answer is wrong and your program's not doing what it's supposed to. And then you spend like hours debugging only to find out that, wait, I should have been using like a single quote or a double quote. So it's generally good practice just to use one of them consistently throughout your entire program. But there are reasons not to. So it really depends on your situation. But generally, it's fewer mistakes if you stick with one. So that's normally what you want to do with programming, is just try to reduce the possible number of errors that you can possibly make, right? But yeah, that's those are all possible things. So we're gonna try to print this out now with printing it out at the end, but adding everything to this actual variable. And if you actually remember how we add something to a variable, that's a string type thing, where we have like characters within it, is you just take the variable and then you do plus equals, right? And you'll remember that the plus equal operator just takes the variable itself and adds it to something. So like this is the same thing as saying out equals out plus board at index I, right? So these two are exactly the same. This is just an easier way to write it. Like why type out this whole thing, right? You just type two characters and it's a lot simpler that way. And so if we print this out, what are we gonna get? Let's take a look. Yay, we get the board, right? We get the board, but now you'll notice that it's all on one line. And that's not really a good way for us to do this, because now you're gonna have to count every single character in order to get to the position that you actually want, and in order to know which one you're actually referring to. And so to format it, we're actually gonna have to use a conditional statement, right? Adding integers to a string really bothers you. Yeah, it's not really adding an integer here, but you can definitely add integers to strings. Not in JavaScript, but you can do it in other things. You're a systems engineer, but you wanted to stop by and say thank you. Oh, no worries. This is really cool. We get like people from all different skill levels, and it's really awesome. And I think we even get them from like all around the world too. So it's actually really cool to see. So thanks for dropping by. Hopefully you learned something from this. If not, it's just nice to like chill out with everyone in chat. So it's really neat there. But anyway, like we have the correct information printing out, but it's not really easy for us to read it, right? And so how are we going to do this in a way where we add like a new line? We go to a new line each row of the board, right? And just looking at the board, we know that like every 3 will have to go to a new line, right? And so what we can do is, oh, before that, a quick refresher from the last lesson. You'll remember that in order to go to a new line, we'll use single quotes for consistency, you actually escape an n character. So backspace n, speaking is hard, backspace n actually means go to a new line. So when the computer sees that, it'll know, oh, we should print the next thing onto a new line. And so what it's doing now is that every iteration of the loop here, it's actually adding a new line every time that we print out something, right? So the first iteration, we have x here, which is index 0, because I equals 0. And then it goes to the next line because we've already put a new line there. And so that's not really what we want, but now we know how to do new lines, right? And so we're going to need some sort of condition here. We're going to need some sort of condition to make it so that we only do the new line every 3 squares that we print out, right? how can we do this? We could do a counter that sort of does like, that resets every 3, right? There are a lot of ways to do this, but for example, we can do var 3, maybe not the best name, but we can call that var 3, and then every time we could sort of increment 3, right? And then we can say if 3 equals 2, because it'd be 0, 1, 2, then we print out a new line, right? So we could do that, and then it'll sort of give us what we want. We don't reset 3, sorry. Give me one sec. So we have to reset 3 so that each time it prints out, it doesn't just keep going up, right? So you could do that. Oh, actually, it does need to be 3. So we could do something like that. And then we have to actually reset this a little bit better. But a better way to do it is, because we have something that's already counting this, we can just check whether this variable I is sort of a multiple of 3, right? And so if you think about it, like you can take a look at this. So like 0, 1, 2, and then 3, 4, 5, 6, 7, 8. You'll notice that like if we had this as like a regular square, right? So if you start counting at 1, you could have like 1, 2, 3, 4, 5, 6, and then 7, 8, 9, right? So if you think about it that way, every multiple of 3, we're gonna need a new line. And so how we can do that is, first of all, let's, for our sake, just think about like I plus 1, right? And so this way, the computer's actually, even though it's counting from 0 to 8, now when we do this, it'll actually go from 1 to 9, right? And so how can we find out if something is divisible by 3? And I see someone in the chat actually mentioned it. It's called the modulo operator. And so the modulo operator is kind of like division, but instead of doing the actual division, it only gives you the remainder, right? So every time you have like 3 divided by 3, the remainder is going to be 0, right? So you can actually see that. If we, here, before we do that actually, we can print it out. So you can see what the condition actually does. Console.log, and then we'll take this whole condition and we'll just print it out, right? And that's a really easy way to check our work. So let's start with the I plus 1, right? What is I plus 1 gonna give us? It's gonna give us 1 to 9, just like we expected, right? And now, if we do a modulo on 3, right? So this is what it gives us, 1, 2, 0, 1, 2, 0, 1, 2, 0. And what's that actually telling us? So the first thing that it's doing is it's doing 1 divided by 3, right? And 1 divided by 3 doesn't divide into 3. And so the answer is 1. So it's kind of like this. So 1 divided by 3. Think about it that way. And you can think of it in like the long division format that everyone does in school, where you put a 3 inside and like a check mark on the outside and a 1 on the outside. Yes, I am a C++ user. So 1 divided by 3, if we think about it in like long division, right, this would be 0. Maybe I can give you a little bit of a better format. So this would be 0, right? And then if you're in elementary school, you'll say remainder 1, right? Because 1 doesn't divide into 3 past 0. And so modulo is actually doing sort of the exact same thing, but a lot faster than you. And also it's only giving you the remainder, right? And so the next one we can look at is 2 divided by 3, right? And it's very much like the same thing, where 2 doesn't divide into 3, and then the remainder is just 2, right? Because you're left with 2. So 0 times for the 3. So 3 times 0 plus 2 is actually what this is saying, right? And maybe if we take like a larger number, it's a lot easier to see too. So we can take something like 7. Why not? Let's take 7, right? And 7 obviously can fit into 3. Or sorry, 3 can fit into 7 is what I mean. It's the other way around for long division. And so we know that 3 times 2 is 6, right? So it fits 2 times, right? So it should actually be the other way around, right? I sort of mixed up the long division. But 3 times 2 is 6, right? But then the remainder is 1, right? And so we expect that 7 modulo 3 is actually 1. So you can sort of use it instead of the division operator. So let's try 7 divided by 3, right? What's that going to give us? Right? 2.333333. So we know that that 3 times 2 is 6. And so if we do a modulo here, then that will actually give us 1, right? Because that's the remainder you get after you divide 7 by 3, assuming that you're working in whole numbers, right? So it's technically like saying 7 divided by 3, but you're flooring it, right? And I think in JavaScript it's actually math.floor. So you're flooring it, which means you're only taking the lowest whole number that this divides into 3. And then what you're doing here, let me show you what that actually is. That's 2, right? Because 3 times 2 is 6. And 7 divided by 3, assuming you're working only in whole numbers, it can only be 3 can only fit in 7 2 times before it can no longer fit like a whole 3, right? That's a better way to think about it. And so if you actually do that, then you'll know that like you have 0.33333 left over, right? And as a whole number, that's actually just 1. So hopefully that made sense to everyone. But that's basically how modulo works. You can just use it instead of divided by 3, right? So 7 modulo 3, where's my modulo? Why is it not popping up? There it is actually 1. And so that's going to work out the same way for all of the numbers here. And that's going to give us exactly sort of what we want, right? So if we actually use this as a condition, if we check when something divided by 3 has a remainder of 0, that means that it's a multiple of 3, right? 3 divided by 3 is going to have a remainder of 0. 6 divided by 3 is going to have a remainder of 0. And then 9 divided by 3 is going to have a remainder of 0 too. And so that sort of gives us our condition. And that's kind of how we want to think about it when we're trying to break everything down. And so now that we're adding a new line on every third space that we're printing out, now we actually have something that resembles our actual board that we can read out, and it's a lot easier just to see this way, right? And so now that we have that, we can sort of move on to the actual game of tic-tac-toe. So like I said before, we want to sort of break this out into the different conditions that it could be. And this is mostly for us just so we cover all the positions that can possibly win. And this way you can sort of think about like what actually makes you win a game of tic-tac-toe, right? And that's like you can win horizontally, vertically, or diagonally. And so we can do horizontally first, right? And breaking it down this way makes it a lot easier for us to think about it. So we can do if, and then we can take a look at the board positions, right? And what are we actually doing when we're checking if someone is winning? We're checking if all 3 of the boxes that we're checking are the same letter, right? So they can either be O, they could be X, or they could be nothing, right? And nothing is represented by a dash here. You could represent it however you want. Like you can put, I don't know, like an A here or like a number. It doesn't matter as long as you have 3 distinct symbols that you're using to represent each thing, right? And so in order for us to check if someone wins horizontally, you want to check if something is the player that currently just went, right? We have a player variable that's somewhere else in the code that we now have. So we can check if, let's take this out into the actual code where it's not just commented out. But this will basically be the sort of format that we're looking at, right? If board at something equals player. So if this space that we're defining equals the player, right? But we need two more. And so what logic gate do we use if we want all the conditions to be true, right? If we're checking 3 different spaces, then we want all of them to equal the player, right? Because if you have one of them true, then that just means you don't win, right? You need all of them to be true in order for it to be a win condition. And if you remember from our logic gate lesson, that'll be and, because and means that any condition you put here will need to be true, right? And we can sort of copy this over with another and statement too. And this is our sort of, this is going to be pretty much what we do for the rest of this program, right? It's pretty simple once you break it down into this way. And this is like basically the format of the if conditions that we're going to use. And so if you do want like a better way to format this, you can actually just put it on new lines, and the computer will still be able to recognize what you're doing, because it uses like these brackets as the delimiter. So it doesn't actually care if you put things on new lines most of the time. It really sometimes depends on what program language you're using. Python definitely really cares. But most C-style languages, you can like break these up just to make it easier for yourself. And so you can like see what's happening. You could even put spaces between here. Like any space that you put any new line usually doesn't matter. You could do it for like variables too sometimes if you really want to. But yeah, so put it in a way that makes the most sense for you. Just make sure it's kind of consistent across your code, right? And so which slots are we checking here? We want to do it horizontally, right? So let's start with case number 1, where it's just the top row, right? And so the top row, if we look, we can get rid of the one where we shifted it by 1. But the top row is just 0, 1, and 2 in the array, right? And so we can just tell the computer, oh, board at 0, board at 1, and board at 2, right? And what's that actually going to give us? It's going to give us this entire top row, right? And we can actually check that if we want. So instead of doing this, like, remember, you can print out anything you want. So you can do board at 0, you can do board at 1, and you can do board at 2. And I'm just going to comment out everything before, just so you can take a look at only these, right? We don't want to confuse ourselves. We don't want it to print out like a million things here, because we don't want to read an essay there. We just want our computer to tell us this line, right? And so if we press that, you'll see that it's actually showing us the top row, right? So that's an X in the top left corner, and then nothing in the other 2. And it'll keep going if we like keep clicking it, right? It'll show us everything that's only in the top row. If we put something in the bottom row, it's not going to recognize it because we've only dealt with like the first horizontal row, right? Yes, you can definitely put conditions in a Boolean variable. And what that means is, for those of you who are sort of new to this, is you can actually take everything in this conditional statement and put it in a Boolean. So win equals, like, this can be false, this can be true, remember? So if you remember a Boolean, it can either be true or false, or you can put a condition in it. So if you put this in here, it's going to evaluate this first into either true or false, and then it's going to tell you whether you've won. So for example, if you had like 3 O's here, right? Then it would actually go through like this. It would see board at 0, right? Board at 0 is O, which is player, right? That's the player that just went. board at 1 is O, right? Which equals player. So this is going to be true, and this is going to be true. And then it's going to go to this third one. It's going to say, oh, board at 2, we know that's O, right? It's going to take a look at the board array and take the third slot in it and see, oh, that's an O in there. And it's going to check whether or not it's equal to the player that just went. And the player that just went is O. And so how the computer sees this then is that it's true and true and true. And if all three things are true, then this entire thing evaluates into true, right? And so if we put that, we can actually just put something here, right? And that'll work the same way as if we had everything in here, right? And a way that you can actually check that is that you can put another print into the actual if condition to see whether or not the computer is actually going into it. So it'll only go into whatever's in the curly brackets if this condition is true, right? Remember that? So it was true. Now let's say that. And you'll see that this is not true. This is not true. But now it was true, right? Because all three of them are the same thing. And so you could do that. We don't really need to because we're going to have a lot of those. It's not really going to be a good idea to sort of have different variables. I guess you could name them if you really want. Like if it helps yourself organize it, you can have like variable like row 1 or like variable row 2 and then do all these conditions. It's up to you. Either way works. So whatever you like to do, whatever helps you sort of write this out and sort of wrap your head around it, that's fine too. And so now that we have this, what do we want to do once we know that someone wins, right? So let's comment this just so we can remember later on, or so whoever's reading this later can know what this is. And this would be win in row 1, right? So player wins in row 1. And that's basically what this condition is saying. And so if the computer knows that this is true, how does it set the winner? Well, remember we had the winner variable, right? And we can actually check this outside too. So if we actually have winner and we set it to X, what's going to happen? Let's comment out everything. What's going to happen if we set winner to X? And the best way to check this is just to do it, right? So if winner is X, X wins no matter what, right? You can set this to winner is O and then refresh it again. Make sure to save your file so the changes actually propagate here. You can click anything and O will win, right? See, it says O wins even though you put an X. So that's how we sort of tell this game that someone has won, right? And how that works is another part of the code is actually checking that. You don't really need to worry about that. If you do have time as like a very bonus question, it'd be nice if you like go through and see what the code is actually doing and see if you can recreate it yourself, or just like delete everything and see if you can like fill out the parts that I've done for you in order to make this template. But you don't have to worry about that now. We're mostly just learning arrays right now. So that's like a very extra credit thing, if you will. So now that we have this condition, we want to set the winner to someone once they win, right? And who is that someone? Who would win in this case? Well, looking at this, it would obviously be whoever the player is, right? And the player can either be X or O, but it's provided for us. It's given to us from somewhere else in the code. And so we can just set winner equals player, right? And that should give us something. Exactly, player. There's a little bit of a delay, so that's exactly right though. Good job. And so if we do this, remember that anything down here sort of won't affect it, right? Nothing happens here. But if we have 3 X's on the top, then we'll see that X wins, right? And since we don't have any other conditions, wins in other places won't do anything, right? Only if it's the top. And we can check the different cases too. So let's make sure that like we don't win accidentally if there are different things in the top, and it looks like we don't. So make sure just to check like all the different possibilities that can happen. And well, I shouldn't say all the different possibilities, but try to get a good coverage of like the most common cases, and make sure to get like those tricky sort of edge cases to make sure that like your code is doing what you expect in all the situations that people are going to see, to a reasonable extent. Like obviously you don't need to like, if this were like not 9 squares, you don't need to like go through every single square and do it, but just for like your peace of mind, just so you sort of are more confident that your code works, try it out to make sure that it's not like a false positive, right? Like for example, if I just made it so that any 3 placed would trigger a win, like if this triggered a win, then if I only tried to do this, right, then it would win, and I would say, oh, my code works, my tic-tac-toe game is great. But it wouldn't actually work, because anytime you place 3, it would say you won. So there are a lot of false positives that are like, it could get you like that, but just make sure that what you're writing and what the computer doing is actually sort of aligned to what you want it to do, right? And so now that we have this, what we can do is move on to the next row, right? And we can sort of just like copy and paste this over. So if we want the player to win in row 2, and we're going to be doing basically the exact same thing. Instead of 0, 1, 2, it's going to be 3, 4, 5. So a lot of this part is going to be copy and pasting. The way to sort of get around this is to actually use for loops, right? And I don't think we're going to be able to get to that today, but if you do want to try it out for yourself, that'd be really good. I do have the solutions up with the for loops. So if you want to see one way to solve it, you totally could. There are a lot of different ways that you can solve this, especially with for loops, but that's just one of the ways. So if we do this again for the second row, oops, sorry, I need to not win in the first row. But if we do it in the second row, you can see it works now, right? Yeah, there's definitely a very clear pattern here. And where there are patterns, it's always a really good opportunity to be able to automate some of that work. And so if you can have as little copy and paste as possible by making the computer do more of the work and having it figure it out itself, then it'll save you a lot of trouble and it'll make you a lot better of a programmer. And so this one would be 6, 7, 8. And since right now we're sort of learning about arrays, it kind of helps, I think, to see this written out. So you know like which indexes are equal to which parts of the board, and like how arrays actually sort of work in storing the data, and how computers sort of take the data and know which one you mean, right? And so we can do something like this, and then that means this row will work. Whoops. This row will work, and the last row will also work. So this is only horizontal. Anything vertical right now won't work, but we sort of have this. And remember that you sort of want to optimize this as much as you can. And you'll see that if you do win in one row, then you don't need to check any of the other rows, right? Because that just doesn't make any sense. So you can put like else if all of these, because if you win in one row, that's it, you're done. You don't need the computer to like go through all of this, right? Because if you don't have the else ifs, then it'll actually like check everything, right? Even after there's a winner. So this will sort of alleviate some of that, where if one of these wins, then the computer won't continue on to check the next ones, and it'll save a little bit of energy that way, right? So this is row 3, obviously. Cool. And what else can we do? Well, we want to check whether the player wins vertically too, right? Like we just said. And it's going to be very much the same thing. Now, do we want to use an if or an else if here? Now that we're switching to vertical, do we want to use an if or an else if when we're starting the vertical conditions? Give everyone a bit of time to answer or to think about it for the delay. But if you answered else if, that's correct. If you answered if, the reason let's think about it. Why don't we want to use an if here? And that's because if you win horizontally, you've already won, right? It doesn't matter which of these three that you've won with. You've just won, right? And that means like if you've won, like you really don't need the computer to check if you've won like another way. If you won horizontally, you don't need the computer to check if you've won vertically, right? Because it's impossible for you to have won vertically if you've won horizontally, right? And so we would just use an else if, right? So let's continue on this. So these are all the vertical ones, these three. And then we can start using else ifs, right, for the columns, for column 1. And I'm going to spare you a bit of this. It's going to be very much the same. It's going to be 0, 3, and 6. And also, if you're using Sublime, a very easy trick you can do is just like, you can click with your middle mouse button and then copy like multiple rows at once, or like you can like do this. It's just very convenient if you line things up, but you definitely don't have to do it. It's just like a nice trick, right? So 0, 3, and 6 are the ones that we need. And so we can check that real quick. It's generally nice to try after each thing you do, but for something like this, I think you guys sort of get the idea of it, right? I don't think we need to like go through all of these. So I'm gonna do 1, 4, and 7 here. And then also do column 3, which is 2, 5, and 8. And now if we try it, we should try the first row, try the second row, that works. Try the third row, yes, right? So now we have both vertical and horizontal, right? Now what's left? Diagonally. How would we do this? How many ways are there to win horizontally, first of all? Or sorry, not horizontally, diagonally. Because so far we've been using 3, right? 1 for each row or column. So that's already like 6 if conditions, right? And let's take a look actually. So you can feasibly start in the top left corner, right? And you'll get these 3. So that's 1. That's 1 condition. You can also start in the top right corner, right? So that's 2. Where else can you start? You can start from the bottom here. But that's the same as starting from the top right, isn't it? And same with the bottom right. It's the same as starting from the top left. And so is starting from the middle. It doesn't matter which order you start in, right? Because tic-tac-toe doesn't care about the order. It mostly cares about where you've placed everything, the position of everything, right? And so there are only 2 ways that we can win diagonally, which means how many if conditions do we need? We need 2 if conditions, right? And so we're going to keep using the else ifs because obviously if you won vertically or horizontally, you're not going to be winning diagonally, right? So it's the same sort of idea. Exactly, else ifs. Good job, chat. And so we still need to check 3, but which 3 do we need to check? Here, let's take these all out, right? Wins in the first diagonal. Let's call it like top left to bottom right, right? And so the middle one's always going to be this middle one. So let's take a look. That's 0, 4, and 8. And the other is 2, 4, and 6. 0, 4, and 8. And then we're just going to copy this over, right? And this is top right to bottom left. And so this is 2, 4, and 6. And let's try this out. So let's try the first diagonal. Yeah, that works. Let's try the second diagonal. Yay, it works. And just for a little bit of extra, let's try it from the bottom too to make sure that nothing has gone wrong. I know it seems kind of redundant right now, but when your code starts getting more complex, like you definitely want to start checking things that seem like they should work, that in your mind, like there's no way it doesn't work, but you should check it, you know? It doesn't hurt anyone and it'll save you some headache later on. So if it's something quick to check like that, it's fine. And so you'll see like we're already done our tic-tac-toe game, right? That's everything. You can win any which way now. You can play with all your friends. And that's all well and good. But what if you don't want to type out all of the indexes like this? So you don't want to have to like refer to this every time to see, oh, like this is, the middle one is 4 and the last one is like 8, right? And there's actually a bit of an easier way to represent the board. And that is, you can actually use something called a 2D array. And what a 2D array is it sort of has rows and columns that you can address. So instead of doing like what we've been doing so far, which is like board at a certain number, right? Board at either like 0, 1, 2, 3, 4, 5, 6, 7, you can actually do like board at row 0 in column 2, right? So if we do 0, 2, I've actually written it out for you. 0, 2 is actually over here, right? 0th row, 2nd column. So that's a much easier way, and it's a lot more representative of what we're doing now. And obviously, like with 9, it's easy to type out the grid and just reference it. But if you're doing anything more complicated, like you're actually making like a pixel game or like something with blocks, even if it's like 3D, like they're going to be sort of mapped to sort of tiles, right? If you're making a game like that, or even anything else, like 2D arrays are very useful. And they seem to fit better with this board model that we have right now, right? 2D array. Exactly. It's called a 2D array. Exactly. But so what we can do is we can just delete everything. Normally you could just comment it all out, but since this is kind of throwaway anyway, we're just gonna delete everything else, so it's a bit easier to see what we're doing, right? And so how do we do this using a 2D array? Well, actually, maybe it makes more sense to keep it here, just so we can actually reference it later, but make sure that we have it commented out. Right. And so the when conditions are going to be the same. Like if you think about it, what you're trying to do is pretty much exactly the same that what you've just done. But instead of using like one single number to tell the computer which box you want, you're actually using 2 numbers, right? Oh yeah, no problem, Yui. Thanks for joining us though. It's nice to have you here. But yeah, you made it just in time for the 2D array version of this, so that's always fun. But let's try printing this out first, right? Remember that what we had before, we can actually just copy it over. Let's take a look, right? So this is sort of how we formatted it before, right? And we don't need the 3 counter anymore because that's another method that we were using. But instead of this, what we can do is, so let's try printing this out. But now, since we know the rows and columns, right? We don't have to do this all in one loop, right? Doesn't it make more sense to, for each row, go through all the columns, right? So we can do row 1 and then do every column in row 1 and then do row 2 and then every column in row 2 and then row 3 and every column in row 3. But how would we do that? Well, remember when I said in the previous lesson that you can actually put loops inside of each other, right? So let's think about it this way. Like there are 3 rows, right? We can call this row, right? That might make it a lot easier if we just call this row. And we can call J column. Here, let me make all the i's row first so we don't have any remnants there. And then we can call these column, right? Column is less than 3 because there are 3 of each. There are 3 rows and 3 columns in each row and column. So we can sort of do this, right? And let's think about what the computer will actually do here, right? So it's going to take the outer loop and then it's going to go in here, right? And then it's going to go into the inner loop. So what'll happen is when row equals 0, right? Let's think about it this way. When row equals 0, it's going to go in here. It's going to start looking at whatever's in here, right? Stuff. It's going to start looking at this stuff. So it's going to do all this stuff, and then it's going to increment column, right? So it's going to do column equals 0. It's going to do column equals 1, and then it's going to do column equals 2, right? So it's kind of like that. We can sort of type it out here, right? Row loops usually outside, column loops usually inside. Yeah. Usually that's the case just because of like how arrays are indexed. It might change depending on like what you're trying to do, but as long as you remember which is which, it's fine. Like I could switch these around. It doesn't matter. But that just means like we'll have to switch it around when we're addressing our array, right? And I'll show you what I mean in a bit, I guess. So this is kind of how the loop goes. So it's going to go for row 0. It's going to go column 0, column 1, column 2. And then it's going to do the same thing for column or for row 1, right? And then it's sort of going to reset this again to column 0, column 1, column 2. No, it doesn't matter. It matters for yourself. And convention is generally to do it like this, but honestly, like, it doesn't matter. Depending on what you want to do, as long as you remember which is which, it's fine. And then it's going to go row equals 2, right? And then it's going to go column 0, column 1, column 2. So this is exactly every single thing that this loop is going to do, right? So this is the outer loop, this is the inner loop, if that's how you want to think about it. So like, for example, if I just print out console.log, row, and then column, right? Let's do that first before we do anything else. Let's get rid of this. Right, so if we print that out, you can actually see what's happening. It's row 0, column 0, row 0, column 1, row 0, column 2, and then row 1, column 0, etc., right? And sometimes it might help you to write this out if it's hard to wrap around in your mind at first, but eventually like this is going to be sort of a lot more intuitive for you. But basically, this is kind of a really easy way to print out 2D arrays, because if we think about it, we already have the row number and we have the column number, right? And so what will happen if we print out the board 2D at row and at column, right? What happens now, right? It actually prints out X and then the rest of the dashes, right? Which is exactly what we wanted. We're going to need to do some formatting again, but it's a lot easier for us to address like the rows and columns separately instead of having to look at this board and like counting which one is which, right? It makes a lot more sense when you're doing something that's easily representable by like 2D, or like something that's like an array within an array, or arrays within an array, right? And this is sort of called a nested loop if you care about the naming of it. But yeah, like you said before, like we could definitely switch these around too. It really doesn't matter. You can have column on the outside and row on the inside. But if we do that, you just need to remember to switch over row and column, because you don't want to get confused at which one you're referring to, right? Because, for example, if you want row 1, column 2, right? If you switch them around without switching these two, then it'll actually do row 2, column 1, which is this. That's something completely different, right? It'll just invert your array. So if you're going to switch them around, feel free to, but make sure you change your array indexes, right? So if you do this, it'll show you the same thing. Here, I'll actually show it to you if you accidentally reverse it, right? And that'll actually do the wrong thing for you. In this one, it's actually fine because it's 0, 0, but in case you do like this one, it's going to be the wrong thing, right? The order does actually matter for some languages, but nothing that we're doing will probably touch that right now. Yes, in C++, it definitely makes a difference sometimes, although it still really depends on what you're doing. If you're doing something like this, you're never going to hit a point where it actually matters for performance. Yeah, there are micro improvements you can make, but for like a very simple nested loop like this to print out an array, I think regardless of language. And I don't want to speak for all languages, but for a vast majority of them, it won't matter either way. But yeah, now that we're printing this out, let's do a little bit better of a job to format this. So we'll do our out plus equals thing again, where we're storing it into a variable before we print it out at the very end, right? So if I run this again, it's going to do the exact same thing that it was doing before, except without any new lines that it's printing to. And now though, since we're using rows and columns, now we already know which row that what we're currently printing out is. And so we really only need to add a new line for every new row that we reach, right? And so this way, we don't actually need to do any modulo math. We don't need to count it ourselves, and we don't need to figure it out. We kind of already know, right? Because every new row is just at the end of here. Once we finish all the columns, right, this will go column 0, column 1, column 2, if you remember from what we had before. And then we should just go to the next row here, right? So we can just print out the new line here. Yeah, you definitely need like thousands of assignments for it to matter. But if you're doing anything big or anything related to graphics actually, where the scale of what you're working with is like really big, it actually does matter. Like even the smallest things, it's kind of like the thing with butterflies and their wings, right? The butterfly effect, where even the smallest like flap of their wing can like change monumental things because like a chain of events and they sort of like add up, right? And so it really does matter for that. For us right now, we don't have to worry about it. I think it's safe to say. But yeah, now it's a lot easier, right? We've gotten rid of this whole condition where we're sort of like trying to find out if it's in a new row or not based on this number, right? So it's just a lot more simplified, but it gives us the same thing, right? It'll show us the actual board, which is exactly what we wanted. And so the next part of this is going to look very, very familiar to you. It's just going to be a lot of copy and pasting for this. We're going to do the horizontals, the verticals, and the diagonal ones, right? And hopefully we can sort of like speed run this a little bit because I think all of you sort of get the idea of this hopefully now. But just to show a little bit of an example, so you're going to have the same sort of format as we did before, where you're sort of comparing the board position, like the space in the board, to what the player just played, right? And so you're going to have this, and then you're going to have this. We're going to put it all on sort of one easy to look at alignment. So it's a lot easier for us to just like go in. And so if we look at horizontally, everything in this row is going to have the same row number, right? And that makes it really easy for us. We just go in and put 0 here. For everything in row 1, right? Remember, player wins in row 1. That's the condition that we're trying to do right now. Like that. And it just makes it a lot easier for us to do this. We don't have to like go up and count again. We don't have to look at this. We can if we want to, if it helps us. But we're taking row 0, 0, 0, 0, 1, 0, 2, right? 0, 0, 0, 1, 0, 2. And that's really all we need for this. Winner equals player. Right? And let's try that out first. We have accidentally made something happen. Let me see where that is. 178, which is over here. Oh, it's because I have an extra and. Sorry about that. That's what happens when you copy and paste sometimes. You forget things like that. But if we see that, let's try winning in the first row. And that didn't work because... I did that. Oh, because we're using board. Sorry, we need to use board 2D because that's the 2D array that we're using. So there are a lot of gotchas like that if you don't name your stuff right, or like you do messy copy and paste jobs. So those are just like common things to be wary of. It happens to people all the time. So if it happens to you, it's fine. It's just kind of annoying to like go through and search for it sometimes. If you don't catch it like immediately, then you're going to feel so bad when you like find it after like 2 hours of searching. So now let's try it out for the first row. And yeah, you see that works. And obviously, since we haven't done it for any other row, it doesn't work yet. But what we can do is we copy this over and start doing exactly the same thing, right? So we'll take this and this. So this is row 2. I guess we can copy it with a comment in case that helps us a little bit, right? So we'll take these and make sure these are else ifs, right? Else ifs. And then let's sort of move this over here so it's a little bit easier for us to just address all of these. So this is going to be row 1, or row 2, I mean, but 1 in our array index. And then this is going to be row 3, right? Perfect. And so that's going to be all of our horizontals. It's going to work here. It's going to work here. Yes. And then now we're going to do the same thing for columns, right? We're doing this a little bit faster because we've already gone through this sort of process before. Now we're just like changing up the numbers a little bit, right? But you'll notice like it's a lot easier to see immediately what something is based on having 2 numbers, the row and column, instead of just like what is 7, right? You have to sort of count it like 1, 2, 3, 4, 5, 6, 7, right? Oh, and then you have to remember, oh, it starts at 0, so it's like 0, 1, 2, 3, 4, 5, 6, 7. So it's just a lot more of a hassle that way. This is like a much easier model for something like this. Obviously, like both work. If you really want to, like you could do it the first way we did, where we just use a 1-dimensional array. But why not use a 2-dimensional one if it sort of matches exactly what you're trying to do, right? You're just making more work for yourself. To the computer, it doesn't really matter. To you, yeah, it matters a lot. And like, again, since we're doing something small like tic-tac-toe, you could feasibly just get away with this. You could even like copy and paste most of the things and just hard code something and it doesn't matter. But later on, once you start making bigger things, once you start making anything like a little bit more complex, these types of things are really going to help you. Like doing it the right way and knowing the best practices is really going to save you time, you know, and it's going to make you a better programmer. That's just how it works. And so we can copy and paste this whole thing. Yeah, make 3D tic-tac-toe. You totally could, right? You just need an X, Y, and Z axis. So there are actually like 3D arrays. So you can keep making like arrays of arrays to any number that you want. It gets a little bit complicated for you to think about, but 3D arrays are actually used a lot in like rendering and like anything that's like 3D graphics, right? Because it has an X, Y, and Z coordinate that you can sort of reference. So it's used a lot in gaming, especially, and in anything that sort of involves 3D, and for other purposes too. But it's very prevalent there. But yeah, let's start doing the rows. Let's do player wins in column 2 and column 3, and make sure this is else if, because if one of these are true already, then you don't want the computer to go and have to evaluate all the other ones, right? So else if. This one's going to be a little bit different because it's the row that changes now instead, right? And then all the columns are going to be the same, right? If we look at everything in column 0, you'll see that this part changes now. That's the column number instead of the row. But it's basically just the reverse of what we've done here in row 1, right? So you can do 0, 0, 0, 0, 1, 2. And then these two are going to sort of also be the same here. Same idea. And then 2, 2, 2. And then we can just check our work really quickly here. Make sure we're winning in every single column where we're doing this, right? Yay. Okay. That's kind of what we wanted. So it's always nice when things work. Now let's deal with the 2 diagonals, right? For the 2 diagonals, there's really not too much we can optimize with that, but now the numbers are going to be a little bit easier. And that's sort of the only difference, really. So if we take this, the player wins from the top left to the bottom right. So we're going to need to make this board 2D, right? If you remember. And then we're going to need a second row here too. Or a second index here. Because we need, remember, we need two things to address one space, because now it's a grid. And so let's take a look. If we go top left to bottom right, then it's 0, 0, 1, 1, and 2, 2, right? And we just fill that in. 0, 0, 1, 1, and 2, 2. And it's actually going to be the same middle one, right? Because the middle one's always going to be the same now. It's not going to be a random number like 4, right? It's going to be row 1, column 1. So you already know that. And that's what makes this like so much better for something like this, to use like a 2D array instead of a 1D array. And so if we look at this, you'll know that row 0, column 2, row 2, column 0. So those are the two that we need for this square and also this square, you know. And I accidentally put it in here. So fix that. And then we can test it out, right? So there's the top right to the bottom left and the top left to the bottom right. And make sure that we do it like the opposite way just in case. But we really don't need to, because like you'll know that the order doesn't matter because you're checking any of these, right? Like I could feasibly switch these two, right? I could switch these two to 0 and 2. And it doesn't matter to the computer which one it does first, right? Because to the computer, these just evaluate down to true. The order doesn't matter here in this condition. The order would matter if we changed up the condition to something that involves like ors, because much like math, the order of operation matters a little bit there. So if we did like board or, right, this board equals player, like it does the and first before the or. So it's kind of the same way as when we said it was like multiplication and addition. So or is very much like addition, and is very much like multiplication. And in that same way, like it prioritizes and before or. And the way you kind of get around that is the same way as math, where you can actually use like brackets, right? Within like this or something, so that it does everything in the brackets first, and then it does everything outside the brackets, right? So just things to remember there. But in any case, like this actually means that we're just done with this tic-tac-toe game. Like everything should work as expected. And then we still have the condition where we have the tie that hasn't broken. But that's arrays. It's that simple. Like arrays are just a little bit of an elevated variable. It's like a super variable where it can contain multiple variables in it. And that's what I kind of want as the takeaway of this, right? And so now you've done tic-tac-toe. That's your second game already, which is kind of cool. Make sure to try this out yourself. If you haven't been following along, you can feel free to just like take your own time and do this. I do have the solutions up on GitHub. It's the same link. Just make sure to go into pull request. It's one possible solution, but if you see like anything that's a little bit different from yours, or like it's very different, it really doesn't matter too much as long as it works, right? So just test it out. See if it works like tic-tac-toe, which if you didn't know about before, now you know how to play tic-tac-toe and you know how it works. So you're all experts now. We're ready to go pro there. But yeah, that was today's lesson. Try this in for loops. So once you do have it with conditions, I would very much recommend you to try it in for loops. I do have a for loop solution there for the 2D version. The 1D version will be around the same, except you'll have to sort of do the math similar to what we did here in order to find like rows and columns. So it's a little bit trickier, but if you're up for the challenge, go for it. Using the for loops isn't that much harder. Just do it for practice maybe, or if you just feel like it on the day, or you really love tic-tac-toe, try it out. Exactly, competitive tic-tac-toe. People do it for Rubik's Cube, so why can't we do it for tic-tac-toe? Tic-tac-toe is just like a 2D Rubik's Cube. But yeah, thanks so much everyone for joining today. Hopefully you learned a little bit about arrays and tic-tac-toe, I suppose. And I'll see you all on Saturday. I don't think we have a plan for Saturday yet, but we're gonna come up with something. Maybe we'll visit Minecraft again, see what everyone have been up to. It'll be really cool. I think it's been a while since I visited it, so it'll be really neat to see. But other than that, thank you so much for tuning in. Hope everyone has a great rest of their Wednesday, and then I'll see you all soon. Good night, all.